Hello, Denver. Woo! Where's my builders at? Yeah. Hey, hi, everybody. My name's Dan Finlay. It's great to be here. This is my first ETH Denver. I've always watched from afar, just the biggest FOMO of the year, every year. So I'm here. I helped make MetaMask, and I'm here to share something I call Delegatable. Yeah, thanks for coming down. A lot of friendly faces here, and it smells like they auction cattle here, which I heard they do. So for those viewing at home, just imagine that. Hey, so first of all, why delegatable? So what I'm talking about here, it's a general purpose delegation thing. So when we're interacting with smart contracts today, maybe you have a method name, or maybe you're calling a function. There's kind of this ambiguous, like, what are you, maybe you hope for simulation, but where's like we want like security, we want scalability. There's a lot of things that we want, but I'm just going to start with like a word of wisdom that this grounds me a little bit. All I know is that I don't know nothing, okay? And when I'm interacting with new smart contracts, I'm coming at them, and the truth is I'm usually not reading their source code, and even if I do, they might have slipped in something, right? And there's risk, right? There's risk with every opportunity that you take. And you kind of have to approach things with a little bit of carefulness, right? And it's not that we don't want to take risks. We want to build a society that's better, right? We want to cooperate. We want to do cool stuff. But we're in an environment full of these terrible, nasty little tricks and bugs and mistakes, and we have to navigate those, right? So how do we interact with the smart contract world, where we can kind of take careful steps one at a time into the world and cooperate a little better? And ideally, maybe we can learn from nature a little bit and make dynamic webs of trust. I believe that from simple primitives, we can make highly composable, highly secure, highly resilient systems. And that's kind of some of the underpinning that contributed to this SOLIDITY framework. You can add it to any smart contract. So what is it? It's a tool. It's not a standard. I'm not trying to force you to adopt it. You don't have to. You can fork it. You can make your own version of it. You can pull request it. You can just fork it. You can just do whatever you want with it. As it is a usable thing. It's a concept. It's an approach. Okay, and I want you to think about how your users interact with your applications in a way that allows them to be safer in general. If you make a contract that users are getting phished on all the time, then your contract may have interfaces that are a little bit hard for users to reason about. So it's our responsibility. It's my responsibility as a wallet builder to make my users as safe as possible, but it's a partnership. Every single application, you're trying to keep your assets secure within your users' hands too. It's a recurring need. People are implementing approval methods for basically every single smart contract there is. ERC 721 has approve, and of course set approval all, which if ERC 1155 only has set approval all, so every time you interact with a contract and give it a NFT, you give it all your NFTs, and that's how people get drained for all of their apes with a single signature. There's been several different token standards, all slightly different approval interfaces. BitDAO has one delegate approach. Compound DAO has another delegate approach. Moloch DAO has another one. There's questions, when you delegate, is it a full delegation? Can they do everything you can do? You can see Moloch DAO has a special check. They're like, oh, some things only the delegate can do, and some things you can't delegate. That seems kind of arbitrary, right? Everybody's kind of got a notion that you should be able to share what you can do with smart contracts, but they don't have a generalized approach for it. What we need is just a lucid way of approaching. What does it mean to have something and share it in a selective, careful way, okay? So let's just visualize it in simple terms. You've got a contract, you got an account, you've got some stuff in it. If you're in this audience, you might have some stuff in a crypto account. Just kind of profiling here. Okay, and you might have some friends that don't. Now, kind of the beginning of collaboration, whether it's starting a local cooperative or a business or paying a courier to transport something, you need to give them access to something, right? Now, you could just transfer it all up front, but maybe they don't even need all of it, right? So you give them a signature that gives them some virtual access to what you have. You both have access to it. We've now expanded the agency of the overall collective. Now, you might be concerned, could they steal all of my money? Well, I'm glad you asked, because on each one of these signed delegations, you should be able to add little, we call them caveats, little knobs. You can kind of mix and fade down what they can do. And you want to be able to tune down what you're granting to the smallest amount necessary for the job to get done. This is what security folks call the principle of least authority. We want to tune it down. So if it's money, the allowance is the thing, right? Tokens, they all have allowance, but allowance is just one dimension, right? Is allowance the universal delegation thing? No, this is a computer. We're building on the EVM. We can do anything, right? Why not a time limit? Yeah, of course, timeout limits, that's like an obvious one, right? Streaming payments, that's just a different kind of allowance, right? It's just like a little bit of logic. Each one of these is a parameter that points at a smart contract that you can deploy at runtime. So these are just completely extensible. You can just add new knobs onto this, and you can say, only this method, you can say only for this long. You can make whatever caveats you want. If it's your personal token, maybe you're sharing minting rights. Maybe I'm doing an event and I'm giving out the rights to buy tickets. And I say, oh, you get a tranche of 10, you get 50. You know, I don't have to be limited by role-based access control, or maybe there's only 5, no offense, right? Where there's 5 roles, but I could have highly granular. Every single individual could have their own role, or if there's a recurring need, you know, you can start rubber stamping a set of these caveats. And these signatures, these signed messages, use the EIP 712 format. And that means they're inherently readable in basically every Ethereum wallet today. Now, the terms, they're going to be readable soon. We got to make those a kind of polymorphic type. But what you've got is you can see that we've got a delegate. If you've got a great wallet that you're using, you'll see your address book entries show up. And then you'll have a list of caveats. And you should be able to scroll down those and see the exact attenuations that you're applying. And so you should be able to have very multi-dimensional, very fine-grained and deliberate attenuations. And eventually, wallets can start adding maybe the ability for users to add their own additional attenuations at signing time, for example. So that lets you take something that you have, share it with another account. It could be a multi-sig, it could be a contract account. There's a fork of the Delegatable library today that works with ERC 1271, so contract accounts are able to do this just like any other one. And then, with the same signature, this is all off-chain, that multi-sig can assign to their friends. They can maybe delegate. They could be a whole DAO, and they've now got subcommittees, and they've issued some sub-budgets, for example. Or maybe you're managing your upgradable token contract, and you want some people to be able to moderate the inflation policy and other people to freeze the whole thing, right? And maybe they want to delegate because they get so big, their offices are getting very full, they need to hire a staff, they get some helpers, and those helpers are actually, they're writing some scripts or bots or something that they don't want to give their main key to each device, right? So they can, each one, attenuate every bot, every subcommittee, every DAO, every friend to exactly the access they need for the overall system to be as empowered as it needs to be. And that's all off-chain. That's not a single transaction there. That means every single one of these invitations doesn't even need a wallet. You can basically make a link that lets somebody redeem this in a website, and they can actually they can invite additional people without a wallet, and they can sign actions that somebody else could submit to the blockchain, right? To submit to the blockchain, someone's got to pay the gas, but they can be batched and meta-transacted. Oh yeah, and you know, indefinitely, it's recursive. Oh, hey, fun fact. Did you know that fungal networks from different colonies can connect and share resources in a process called anastomosis? Just like 2 different organisms connecting and sharing resources. Isn't that crazy? Similarly, 2 different delegation networks could connect and overlap, and people from 2 different organizations, DAOs, could now have access to shared resources, potentially in a mutually beneficial way. We're trying to build a mesh of mutual support, right? Who knows how that fun fact might apply to you. Let's just review a couple key terms I just burned past. We've got those tickets. Those are delegations. Anytime you want to share something that you can do, you would sign a delegation message. And there's those little knobs. Those are caveats. Every knob lets you turn down the delegation. You can turn it down in any way. Every single one of those knobs is defined by a smart contract. It's got a really simple interface that you can just define. You can just write them. Like your application may have specific needs that you might want to tune, and you can just write them. And then, yeah, the delegation just kind of looks like this. It's a really simple struct. It's got a delegate. It's got an authority, which is 0 if it's your own ability, or it's the hash of the delegation to you if it's a delegation to you. And then a list of caveats that you got. And the caveats, it's just an address of the contract that will do the enforcing and some information that the enforcer will use as its terms. Again, that's the part we're going to kind of dig in on in the future and make it more readable. Basically, we have to come up with a polymorphic struct type. If anybody wants to riff on polymorphic structs, that's what we have to come up with there. We want it to be readable, right? So we want people to be able to understand the terms they're agreeing to. And then lastly, there's an invocation message. Once you've got a delegation, the ability to do something, you need to be able to do stuff with it. Normal transactions aren't exactly what we would use here because you're not the root account. So you need a way to take that delegation and say, here's the transaction that I would like to perform as if I was the original account. And so you basically make a transaction like you would before, and then the chain of delegations that culminates in yourself. So it's like, by the power vested in me, I do this. It's kind of what an invocation is like. Yeah, just like He-Man. Okay, so this is what a caveat looks like. If you're wondering, how do I make my own little knobs? Like you've got a custom contract. It's one function that you implement. You get the terms that the caveat was given. You get the transaction that's being attempted. And you get the hash of the delegation. The hash of the delegation allows you to have stateful side effects to the delegation. So if it's an allowance, this is how the contract would keep track of the current state of the allowance, right? You don't have to use that. Okay, so there's actually a lot of ways you can do this. Like I said, this is a tool, not a standard. It's just a thing, it's a pattern you can apply to make your contract more general, purposely adaptable, and user empowering. So one way is solidity inheritance. You can just say inherits, my contract is delegatable. And now you get an invoke function and you can submit these invocation function payloads. And the whole thing just kind of works automatically. You can also, we have an on-chain relay. It's very similar to the 4337 relay, except, well, I mean, basically it's good for EOAs, right? 4337 or EAP feet, as some are calling it, is good for contract accounts to have user operations that get bundled and maybe subsidized. But EOAs or accounts that are controlled by a key, they can't benefit from that. But they can participate in this. So this works with contract accounts and traditional accounts. No need to force everybody to migrate at once, even though I admit, I can't wait to migrate everybody at once. And lastly, if you're into upgradable smart contracts like we just got to enjoy in the last talk, we do have a diamond facet. So anyone who's using the diamond standard today can just basically add this facet to their contract and it will just work. So that's the magic of upgradable contracts. I really think that it's a great pattern. I'm sure we could make one of these extensible token versions of it too. Again, it's a tool, not a standard. Oh yeah, same deal as the extensible token thing. Use underscore message sender. This should be buried somewhere in your smart contract. If you're using Open Zeppelin libraries, you already have a message sender defined somewhere, and you just need to override it. This makes the magic happen under the hood. Basically, the account that did the delegating is appended to the end of the call data, and the receiving contract respects that as authority. It's kind of patching the thing in Ethereum that said only the sender of each transaction can do a thing. So we're expanding the definition, and clearly I think it's a positive pattern. I'm pretty sure our two methods are compatible. So my guess is that you're probably better off adding this to whatever your contract is, especially if it's extensible. Okay, so I'm not going to cover all of those approaches. We've got some great documentation on delegatable.org. Thanks to my friend Kames. Let me show you what it looks like to inherit it in some Solidity. This is a MobiMask. It was the first delegatable contract on mainnet. You can check it out at mobimask.eth. It's not verified on Etherscan. The goal was to make it the simplest contract to prove out the entire premise. And so it's a Fisher registry. It's just a mapping of identifiers like Twitter fishers to a Boolean that they're a fisher, right? If you were just a normal contract, there'd be one person who gets to say who's a fisher or not. And don't get me wrong, this trust is rooted in me, and I'm kind of the one who gets to say who's a fisher in this registry. But I have the ability to share that right, and I can do it without a transaction. So I've been just giving out these invitations where people can report fishers, and everybody who gets an invite can invite their friends, and they can invite their friends. And, I mean, fishers are just like Sybil attacking the heck out of social media, and Twitter doesn't seem to know how to deal with that. They just let everybody pick their own names and pictures, right? So it's going to take a lot of us contributing in a lot of creative ways to address Sybil problems. So this is an approach. Sorry, that's context. How did we make it delegatable? You can see on line 7, the contracts fisher registry is revocable ownable delegatable. Now that's like a subclass. It's like a flavor of delegatable. It comes pre-rolled where the invitations can be revoked, right? I kind of pre-rolled a caveat enforcer so it's more gas efficient. But basically that's it. So now you can claim as fisher, and now the whole thing's delegatable. So you can check that on chain if you want to see how it works, and you can go to delegatable.org if you want to read more about it, or you can go to github.com/delegatable to read the code. I'm going to go through some code examples. I don't want to bore everybody to tears, but you want to see that it's possible, right? Like, it's not all the prettiest code, but I'll show you. Okay, so EIP 712 means every signature has some data at the beginning that says what contract you're signing to. And that's how you know that when you sign that message, it's not also useful somewhere else, right? It's the context. So you make your contract info, and then you sign your delegation. It's just like we said before. It's like, who's your delegate? What's your authority? And do you have any caveats? I'm doing it lazy here, no caveats. And we've got a little delegatable utility. You generate it with the contract info, and then you can sign the delegation. You can dig into that. It's just doing a little bit of 712 signing. 712 signing looks a little ugly because you include all the types, and there's this big types blob. So you can crack that open. It's kind of ugly. It's JSON, but all the code in Delegatable is generated from that type blob. So it's like pretty solid. It's passing all sorts of tests, and it's a lot easier to use this way. Once somebody has the delegation, they construct a transaction. On that first line, yeah, sorry, this is a lot. I'm not going to make you read all of this. But that first line, you can see this cool ethers utility. You say populate transaction. This is how you make a transaction data like as if somebody else was making it, right? Because the delegation, you're doing it on behalf of someone else. So we need to make that transaction that they would make. And then we form this invocation method, and it supports batchings, and then we create a typed message and we sign it. And then you can see on the last line, we're connecting our second address, so a different account is relaying it. And then we invoke. So the invoke function is how you batch a bunch of these delegation invocations. I think there's a lot of UX opportunities that come from this. A key thing, you don't need gas to invite people. So, I mean, onboarding, right? Like, what are the key onboarding struggles we have? We've got getting a wallet, getting a backup, getting your first ether for gas. Okay, if you can just send somebody an invite link and it's attenuated down to an amount that you're okay being an invite link, you can just send an invite link, and the first thing they do can just be in an app. And if it's just something like checking in for an event, or maybe claiming an NFT, right? You can make a claim an NFT link, and it'd be free. So yes, you can mint NFTs for free with this, right? I mean, I should have just started with that, right? That should probably sell itself. So yeah, and you could then share the right to get the NFT, or you could have a few or whatever. Having wallet onboarding, don't get me wrong, I'm not trying to sell you off wallets. I've got a wallet, a little vested interest in wallets. But I'm not trying to tell you that every app should start by making you get a wallet and forcing everybody to back up a seed phrase. That's a terrible user experience, and nobody wants to do it, and most users get confused by that, and they're just annoyed, and it's probably totally strangling the whole ecosystem. So how much later could we introduce the wallet? The wallet's kind of for backing up, and it's kind of for paying gas. I think backup is kind of the big thing. So if you don't need to back up yet, if it's a small thing, we can do small things for free, okay? Like let's do a bunch of small stuff. Let's have games, let's do fun things, let's have events, let's do tickets, bring back some fun, dynamic innovation, creativity, right? Or if they want to submit their own transaction. I messed up the thing now. But yeah, if they want to submit their own transaction today, that's the other thing. You need some ether to do that. Although, those Eep Feet fans, I know you're waiting for me to say something about it. Okay, some opportunities. Okay, yeah, I'll get to that in a second. Here's a couple examples. If you're here as a hackathon participant and you're still looking for what you might want to do today, I'll just throw out a couple random ideas. Making DAOs fast and decisive. I think the norm in DAOs today is kind of a little bit of a slow bureaucracy, right? There's like usually like a proposal period, and maybe only so many people are really participating. And hey, don't get me wrong, more and more DAOs have delegation, but it's usually like one hop deep, and then those delegates feel all burdened down, like, oh, like I better, I got my Twitter followers expecting me to vote or whatever. Like, make it fast, make it flexible. Let your delegates delegate, just like spread around the influence. If you don't like how somebody's representing you, revoke it. We should have dynamic organizations that move as fast as we need to be moving, because the kinds of problems that we should be trying to solve are not in the increments of proposal periods. Maybe sharing exclusive perks. I mentioned like events. I really think if you're trying to engage your audience, something like claiming NFTs, participating in your token sale, whatever, like bring back taking responsibility for how you give out rights. Everybody's trying to airdrop or like automate something or like verify it on GitHub, and like I think that's kind of shirking the responsibility. If you know people that you want to share digital rights for, take that responsibility. Do it yourself. Whatever methods you have, it's off-chain. You can be creative. You can be iterative. You can iterate every single Reddit account. It's free. It's off-chain. You can give out these rights, and the only gas payment is when somebody uses these rights. A future version of it would allow you to add a fee to referrals, so you could give somebody a right to do something on condition of payment. I believe there's a breaking change we have to make, or an extension to do that. And oh yeah, the whole thing of keeping your assets on colder and colder devices. So everybody wants to not take risks, right? Just take the risks you want to take. So you want to keep your ape on your cold device, but then I don't know if you want to. Is there any way to use it? Okay, tell you what, we'll get to Worm XYZ and Delegate Cash in a second. If you're just claiming NFTs, you might want a different kind of delegation. But if you've got like a functional like voting token, some ENS tokens, and it's an uncomfortable amount, you might want the ability to transfer them cold, but you might want the ability to vote hot. And then you could delegate that right to vote hot. You could give partial amounts of tokens to vote, perhaps hot. So the ability to keep your assets cold, keep some things warmer, and still be able to log into things selectively, I think there's a lot of potential to keep people safer. Actually use your things that you have safely. Session keys is an example of that, right? A delegation that's time limited to an application means fewer confirmations. So you log in, it can do stuff, it doesn't bother you. It may not even have gas payment, or maybe it sends it to the back end to submit the transaction, meaning you're not bothering users with as many confirmations or gas payment, maybe not even requiring Ether at all. If you're willing to subsidize your transactions, you might not need your users to hold any Ether. Okay. Relation to Eep Feet. So Eep Feet is a great way, like a gas market for contract accounts. Now, Delegatable does feature a batching mechanic, but it's kind of feature overlap. If you have a contract account that has batching, you don't really need the delegatable batching feature, so we're probably going to make a non-batched invoke method. That's basically the answer. Otherwise, they're compatible. One is concerned with a gas market for contract accounts. The other one is a method for any contract to make its resources very shareable. I'll just talk through everything I just said. Yep, like I said. Oh yeah, and Delegatable also provides batching for traditional EOA type accounts. So that's pretty cool. So batching for everybody. I think that's nice. Take care of all your users, not just the early adopters. Okay, now I'll compare it to a couple other current delegation frameworks. I've been saying 2023 is looking like the year of delegation. There's a lot of people who are kind of waking up to realize, hey, wait a minute, I don't want to keep all my assets on my MetaMask, frankly, and I don't want to, and I want to be able to take smaller risks, but I still want to do stuff. And a lot of people claiming airdrops and then getting all of their money taken, right? And that's like kind of a repeating pattern. Trying to claim free stuff, getting your money taken, okay? So Delegatable, like you just saw, it lets you grant anything you can do on a contract to another account. It's got an open-ended caveat system, so you can attenuate the ability you're sharing in any way that you want. And that can let you keep hot while it's cooler, but by limiting what they can do, but they can still do stuff on chain. Now, Delegate Cache and WarmXYZ provide a registry on chain that lets you report another account as your delegate. Now, notice that that is not touching the contract that holds your asset. So you're not sending a transaction to your NFT account. You're just saying to this registry, hey everybody, that's my delegate. Okay, so that delegate account can't do anything with that account. Okay, so that's why it's extra safe. They can't do anything. You're perfectly safe if you can't do anything. And that's really what I want you to take away here. If you don't do anything, you're perfectly safe. Now, that is great for proving ownership. If you want to token gate membership into a chat room, if you want to gate who gets a second NFT, if you want to gate who gets a ERC20, this is a popular use case. I don't want to diminish it too much, even though obviously my interests are a little bit more in sharing what you can do on chain. Okay, so if you're somebody who is trying to keep up with all the latest airdrops, you should sign up for those delegate registries. Sign up for both of them. There's no problem. It's 2 registries. If somebody comes out with 10 more, as long as you're not falling for a phishing attempt when you try to sign up for one, there's really no harm in it, okay? Okay, so that's my talk. 3 minutes to spare. Whew, what will you do with it? It was not rhetorical. I was trying to ask you. I was trying to ask the audience. Sorry. But with 3 minutes, I think I mean, you can ask whatever you want, but I would love to hear if somebody has a different kind of contract than I talked about, and you want to riff real quick. 3 minutes. Super jam. Let's think of a new use case or any question. Can you make a Merkle tree with delegation? Arguably, a delegation tree is a Merkle tree. Can you just make one just like for fun? I mean, yeah, you bet. Any serious questions?
So besides some of the standard enforcers like block number, timestamp, is there anything else that you see might be interesting for enforcers, whether it's like governance proposals or something else that hasn't been written yet?
Yeah, okay, so besides the 4 hypothetical caveats I included, okay, so like an allowed methods enforcer is one of the ones that's like really essential, like what are you letting them do? I think a lot of this stuff comes down to what is the contract good at. Like it might be that you have certain parameters on a function that you want to confine. I mean, I'm not an expert in every DAO's interface, so a lot of this comes down to what's your DAO doing for what kinds of things you'd want to share. So like ENS, if you got an ENS name, well, yeah, it already lets you share who can do a subdomain, but that subdomain owner can't share the right to update the subdomain. So sharing the right to just share that function, that's good. But yeah, other caveats. So yeah, we got time. Are there other? Oh, let's say if it was a subdomain, I might say, hey, you can you can make a subdomain that's anything that has like your name in it or something. I could make little rules, just custom rules. And it's not a very compelling use case, but like, I mean, it really is, I think, use case driven. Like, what are the ways in which you want to attenuate the access you're sharing? Yeah. Yeah? We're going to really make you run all over the place. You want to shout it? No, you don't. Hey, you're out late in a loud environment? Yes? Get better sleep.
When you have a tree of delegations and you revoke, does the revoke cut off an entire branch of the tree?
Fun question. Yeah. So if I've invited someone and they invite someone and they invite someone and then I revoke that first one, yes, it totally breaks the whole tree downstream, because when you call invoke with your chain, right, remember the invocation has an array of delegations culminating in yourself. And in order to process it, the smart contract walks down the delegations and verifies each one's validity and walks down the caveats and checks each one's validity. And yeah, that means each invitation adds a little gas cost and stuff, but it also means that anybody who starts feeling sensitive about who they invited, you don't want to, and this is like a real problem with other access control mechanisms, right? You invite somebody to a chat room and then they invite a whole bunch of other fishers and you kick out the first scammer, but you don't know where everybody else is. Like, So yeah, you want to kick everybody else out.
Yeah, because the problem with Merkle trees is you have to regenerate the entire thing if you want to change one part of it.
Are you trying to do a callback to my?
I'm trying to redeem myself. Yeah.
Yeah. Oh yeah. No. Yeah. You're right. Yes. So if you change that part, yeah, it updates the whole Merkle tree. Yes. Okay, I'm a little over time. I assume there's a speaker whose time I'm stepping on. But yeah, another
One more question. Can contracts delegate as well?
Yes. So in the current version, if you just go to github.com/delegatable, the main branch currently doesn't, but there's a pull request open. I think it's like number 17 or something. It says ERC 1271 support, and that supports contract accounts. We're probably going to tweak it a little bit more, and we're not going to merge it till we also have like a full docs site. So we're gonna cover it real good. But yeah, it's a schema update. So we want to make sure that if you land on the website, you understand how to use it. But all the tests are updated. So if you are comfortable pasting code, you can jump in there, and it works with contract accounts. It's super cool. As long as that contract account implements 1271 correctly, right? Wow. And correctly means actually enforce your contract account's logic. I don't like these contract accounts where they delegate to one signer for their 1271 signatures. You just gave up your whole multi-sig thing. Okay, for a little while I thought 1271 was a bad idea because everyone was doing it wrong, and then I realized it can be done right. So please make sure your contract accounts are implementing 1271 in a coherent way.
Okay, I have a quick question around sub-grantees. So I receive grants from a grantor who receives it from the federal government. And then I give a certain amount of money to all these individuals, and they can use it for very specific things. So is this a use case? This sounds like a really good use case for transparency and reducing, losing the money, right? Not getting it spent on the right thing, having to prove it was spent on the right thing, right? This would be an extremely compelling use case for government contracts, no?
Yeah. I think the way I originally had the idea was thinking about how small organizations would
Especially because
fund
none of
charity.
these people have wallets.
Yeah.
None of these people are on chain.
Exactly.
But these are all money that needs to be tracked efficiently.
Yeah. So yeah, you get transparency in who has a budget. Also, if they don't use their budget, it's not leaving the main account. And if they don't use the budget, you can revoke it and you still have it. So it's expanding who has access to it with a very concrete budget, while keeping. And in fact, you can kind of use this as fractional reserve delegation, right? You could have $100 and you could say, hey, I'm looking to buy this $100 thing. Any of you who can find it, please buy it for me. And as long as you think they're not going to betray you, first come, first serve. You can trust your friend. This is a construct sometimes called incentive trees. Look up the Red Balloon Challenge. It's super cool. Cool. Well, we've got a Discord. Come down to us after the talk for an invite to it. Yeah, another question here? No? Cool? Yeah? Hey! Thanks for coming, everybody.